can you put this on the margin of your paper? So we're doing solving multi-step inequalities day 1. We've got a day 1 and we've got a day 2. Okay, these are the things that I would like you to write down. I would like you to write down the first thing that you do is distribute. And that's, if you see parentheses, you need to distribute first. That's the first thing we do. The second thing that you would do is you would combine, and I'm going to abbreviate a little bit, combine like terms. So put the x's together, or put, constants, the numbers that are just plain old numbers, put those together. Just on the margin somewhere. Be careful of that, it's going to get light. All right, next thing you would do is you would add or subtract. And this means that you're going to maybe put the x's together on the same side. Or you're going to put the constants together on the same side. But we add or subtract by doing that.
So like right here?
Anywhere you have space. And then the last final step would be to multiply or divide. And that's when you're going to get your variable alone. So these are our steps. They are written on the board. Sorry, the screen's covering it, unfortunately. Okay. Okay. The big ideas from 3.1 and 3.2 are going to be exactly what we did on Thursday. Remember how I had you write everything on the board that's green and pink? So let me do it right now. This is less than. This one's greater than. Less than and greater than have an open circle on the number line. Then with a line underneath it, that's less than or equal to. This way, with a line underneath it, greater than or equal to would be a closed circle on the graph. And the thing in pink is when you multiply or divide by a negative number, switch the inequality. So the inequality changes directions. When you multiply or divide by a negative number, you switch the inequality. That's up on the board, green and pink. Big ideas. Okay, let's start. Graph these inequalities on a number line. Label the boundary point. Boundary point means that the point on the line where we draw the open or closed circle, that's the boundary point. So, the first one has a problem because there's a negative sign in front of the x. First problem. So tell me about fixing that. I like you dividing by something, but not just 1. Because see how it's like, this is like a negative 1, but we don't write 1s, so that's kind of a waste of our time. So you're going to divide by negative 1, both sides like that. Ding, ding, divide by a negative number. Switch the inequality. Now my x is all by itself on the left, And negative 3 divided by negative 1 is positive 3. We're done. Graph them on a number line.
Yeah. But if before the negative 3 was greater than, how would it be after greater than?
Because I flipped the inequality, it means that my answers are now going to be on the opposite side of 0. That negative 1, that dividing by negative 1 is what makes you have to flip. It's a rule of inequalities. Okay. Graph it. I'm sure you can do this on your own. Knowing whether it's an open circle or a closed circle, what direction it goes. Good. B. The only problem with B is that it's facing the wrong direction. I really want my x here, and I really want my 0 here. There's nothing to solve for B. And if I put my x on the left side now and my 0 on the right side now, what happens? Yep, change the inequality. Like that. And graph it. This is nice, it's at 0. Perfect. You have to decide if it's open or closed, and then you have to decide what direction it goes.
Right. To the right.
Closed. To the right because greater is bigger. To the right, larger numbers. So that's just a little review. Now we get into it, and there's not very many problems for us for notes on the front side, so we're going to do quite a few on the back side together, and I'll do the classwork with you. On number 1, have a discussion with the people at your table and talk about what would someone do wrong. What is the first thing that someone might do wrong? So we're talking about the wrong thing to do. Talk to the people at your table. So go ahead. So now I want to hear what some of you said. What's one thing that you could do wrong? Add 3 to both sides right off the bat. Someone could do that. That would be wrong.
To subtract the 3 and the 1.
Yes, that's a big one. People will do 1 minus 3 first. No. Why is that wrong though? Because you're supposed to distribute the 3. What else could someone do wrong or forget or make a mistake on?
They could do the parentheses, like.
You could do the well, if you did the parentheses, that would be the right thing to do.
Oh. Okay.
So maybe if they forgot to distribute.
Yeah.
Okay. Yes. All right. So those are mistakes that we will avoid for sure. So the proper first thing to do is what? Distribute the negative 3. So draw those little hoops. The 1 is just going to stay. 1. Okay. Now it's a negative 3 times an x. Don't forget about the negative sign. Now the second little red hoop. A negative 3 times a negative 2.
-6.
Positive 6. Still hearing lots of little errors.
Wait, why is it positive?
Because it's negative 3 and negative 2.
Negative plus negative.
Negative times negative 2, positive 6. Okay, what are now, so I distributed. Next step that you wrote, like on the margin, up above, on top, the first thing we did. Combine like terms.
6 plus
What, though?
1.
6 and the 1. You're right. Don't do minus 6. Don't do minus 1. They're on the same side. They just are together, combined. 1 and a 6 make a 7. The 3x is still negative, and it's greater than 10.
Subtract 7 to both sides.
Okay, let's subtract 7 to both sides. Now I'm doing my adding and subtracting portion of my steps. Let's get the 7 and the 10 together. Negative 3x is greater than 3. All right, do voices. Next. I don't want to add 3x. Yes. So, divide by negative. Ding, 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 ding. Okay. Because I divided by a negative number, it is no longer greater. It is now a less than. Also, positive 3 divided by negative 3. Negative 1. Graph that on the right. Graph that on the right. That means that all of my solutions are here. All these numbers. And forever to the left. And small, small, small numbers. Negative numbers. Forever. Okay, B. There's no parentheses here. I'm not going to distribute anything. But there's like terms. And they need to be put together. 2 and 4. I'm going to do a little star. Star. Okay. Those are the like terms. They have black stars on them. And it's not 6x. I know you put them together. One of them's negative, one of them's positive.
Negative 2x.
Negative 2x.
Wait, how is it?
Positive 2, negative 4.
So that's a negative.
Negative 2x. The negative 3 is still there. I think I need to get some other color in here.
Yeah.
Okay, now let's do red. How about red? Yep. Add 3 to both sides. Negative 2x less than or equal to 10.
5. Negative 5.
More, I like the negative better.
Negative 2.
Oh, divide by negative 2. Ding, 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 ding. Something special happens. So what did you decide? Is it 5 or is it negative 5?
5. Yeah, because how does it positive equals negative equals that?
Negative. Those of you that said negative 5, you got it. Now graph it. And I'm going to have someone help me on the screen. Yeah. Yep. I like it. I think it looks good. All right. So those are pretty, maybe easy, maybe difficult. It's the knowing what to do when. Distribute if you see a parentheses. Put anything together that's the same. So if they're on the same side, get the x's together or get just the plain old constants, those numbers together. Okay, I want to do number 5 with you. I'm confident that 1 through 4 isn't too difficult, but let's do number 5 together. Because number 5 has a lot going on. And the like terms for number 5. What about middle table? I haven't heard from you guys at all. So, what are the like terms for number 5? 4V and 3V. They're on the same side, just put them together. I have 4 V's minus 3 V's. How many V's? 1 V. So I have my 1, and then I also have a 1V. Greater than 4. Okay? Yep. Let's do blue this time. And really, you don't need the 1 in front of the V anymore. I'm just going to put a V. And it's greater than 4, take away 1. So, graph that. Open circle. Greater than. Just like that. Cool. I also want to do number 8. Jump to 8. I'm choosing to do the most difficult ones with you. Okay. You're not going to do 4 minus 2 first. Nope, that is not what you're going to do. Because we already talked about those mistakes that people make that won't be us. So it's the 2. Yeah. Okay, backside. Keep the 4 there. I'm getting over this black, red. How about purple? 4. Okay, negative 2 times negative 4.
8.
And it's a positive 8. Now let's do the other distribution. Negative 2 times positive 4x. Negative 8x. So I have distributed. Write the rest of the problem as you see it, 44. The other thing that I want to do is I want to now combine like terms, anything that I can. Julian, what's a like term that I can put together in purple there? Yep, 4 plus 8 makes what? Thank you. 12 minus 8x is greater than or equal to 44. Cool. Now comes the adding and subtracting portion where I need to get the constants together. Don't deal with the x yet because the 12 and the 44 are like terms. They can go together. So I add 12. I don't want to add 12. Subtract 12. Okay. So now, there's still a negative in front of the 8x, by the way. Ding, ding. Well, hold on real quick. 32. Okay, now. What color is this going to be? Red? Divide by negative. No one's going to do it? Someone just did it. Ding, 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 ding.
4.
Negative or positive? I didn't hear what you said, sorry.
That's negative.
Sure. Okay. Graph it yourself. Less than. Oh, to the left, to the left. I'll fix it in red. I know, I was like all sad. Okay. The red one. Look at the red one. And I also want to do the next most difficult one. You guessed it, number 10. So, I'm going to give you a 1-minute head start on this one. I want to remind you that there is a 1 in front of this N here at the end. So go ahead and start.